Our next speaker is Fabian Cook. He is the president of the New Zealand JavaScript Society, and I will let him introduce himself. Thank you very much.
Hey. Hi all, I'm Fabian. I'm a software engineer. I work for ClearPoint along with Contact Energy, where we're taking a digital-first approach to self-service tooling, enabling our customers and frontline staff to optimize experience and minimize costs for everyone. So we're here today to talk about a fresh take on JSX, and I'm hoping that this here is going to minimize cognitive load for all you developers out here. And yeah, take us oh, sorry. Yeah. Okay, today I'm happy to announce a new era for JavaScript, which is using JSX as a value. So this here, we're currently linked to two parts of JSX, where we've got a production of JSX, which is usually all of us, what we're doing, where we're producing content for our websites or for our apps, or anything that relies on JSX. And then we've got consumption of JSX, which is all of our renderers, like React and tooling like that. So what I'm talking about today is the arrow in between the two, where we've got, we want to take it from our production state to our consumption. So within JSX, we've got a few different things that we can, we can express structure with our JSX, or we can express processes that are happening. For example, a component here is a single instance of one set of processes and transitions and some state. And then when we've got some hierarchy in there where we've given it something, we've told it that everything under here is the hierarchy for so if something was implementing some transitions, the transitions of something was within component. And then we've got sibling hierarchy, where we've got things that are next to each other. These things are telling us that these are processes that happen alongside of each other but aren't exactly dependent. And then we've got information where we've got just static data, where we've got things that we've got some data that we want to represent in our application, and this could be any kind of value at all. So then we can also represent things like entities where we've got some meaning behind it. So in this case, this here is, we would be talking about products or brands. These here we can have information about these products and information about our brand. And we can then group them together and create some hierarchy where we can read this information alongside of each other. So with JSX as a value, we need to be able to reference it as a value. So we've got product here, which we're assigning directly to a product variable. And this here is something that you wouldn't normally see in many other JSX frameworks, because you wouldn't typically want to actually use the JSX value itself. But in our case, we can, and we can, if we look here, this is the exact log of our product. And we can see that we've got each individual thing that we were talking about when we defined our product exactly here. And we can see it right there where we've got the options on there. The key thing about what we're talking about today is this children. And in typical JSX frameworks that we see right now, children is always referenced statically where we would want to have this information right now. And that's really good for most of the JSX renderers out there which are doing things, for example, like diffing at two JSX states, and then using those two things to create a third diff, which is our actual change to our UI. But in our case, what we're trying to do is actually jump in between that consumption and production and read these children right in line where our code is. And so by doing that, we can use for await within JavaScript right here, because our children here was an async iterable, which is something of JavaScript. It's part of JavaScript itself, and we can use it without any additional tooling. So here we can see that if we did define our product with a brand, as that child, we can see when we log it right here, we've got that logged out down here. And this all is pretty cool. It works fine, and it's a straightforward example. We've just got one hierarchy. But if we expand this outwards and outwards, where we've got multiple children and different things going on, and we can create whole user interfaces like we do right now with JSX. So we're not really too concerned about what we can do with our patterns around JSX and how these things are structured. It's just that we know that from the top all the way down, we can read things, read all the different changes throughout that hierarchy. So if we look here, what we're really talking about when we've got multiple, sorry, I might actually go back and talk about, this one here. So if we look here, we've got this product and we've got a brand and we've got some children. Well, the brand here is the children of our product, and that there's directly related to that children variable right there. And when we've got more than one children, we've got a problem where we've got more than one thing to resolve. So right here we've got three things. We've got our horse, bird, and robot, and each one of these resolve twice with two different sets of state. And these here are things that we want to know at some point in time. So the core of this pattern that we're talking about today is the union of multiple sibling children within our hierarchies. And we can see this right here with this function, which is called union, and we're going to pass these three things that are happening, and we want to know what state these three things are in at each point of our iteration process. So we see here we're going to try and log all these three things, and we can start seeing each iterative step as to what we're up to with each thing. So if we look here, we've got the log, and eventually we want to reach a state where we've got our strong arm, and we've got a heart, and we've got a selfie. So we see here at the bottom line we've got that, but we've got some resolution process in there in between. And this resolution process is the thing that you would typically throw out at the renderer itself, and it's doing all this stuff around scheduling and trying to figure out what needs to go on when, and things like that. But from our point of view, we're thinking about it as a concurrent union in between everything, where we want to grab all of these siblings, and we want to know when they're all got something next. And that's what we're seeing right here. So if we think about it then as a JSX tree, we can see we've got our fragment where we've got three children, and they're all siblings of each other, so we want to know the information across those sets of iterations. And this thing on the right here is each iterative step of information that we got along each stage. So we can see that this set of JSX right here is equivalent to all of these states right here. Even though at one point we do want to reach this state, all of these other states that we're gone through were all the same, same thing. So with that, we can create our structure behind it and see how we actually consume our information, and we can accumulate everything together so we can ignore the internals itself. So with JSX, we've got a whole lot of ways that we can actually produce our information. So this is what we're currently used to within JSX, where we go and define a function. So with most of our JSX right now, especially with the current popular ones, we define a component as a function, and we return some state that's going to be rendered into our UI. In this case, what we're actually going to be talking about is not using the JSX framework as a state management library itself, but instead using JavaScript as a state management library. And for functions, what we should be used to, rather than what we're doing now, is having, if you've got a single function, that function typically should do one thing, and it should be invoked once, and it should have one set of state. So we don't need to jump out of that scope of that function to kind of understand what's going on. So right here we see that we've got three different scopes of information. We've got our module scope and our function, and then we can use those within our return state. But what we get from other JSX renderers is we get this additional set of state that gets thrown in there, and that's so that we can keep along, multiple different calls of this function, and that's perfectly cool. But I actually should jump into this one. But what we could do instead is, instead of recreating a new function each time, we could keep hold of one function over the entire life cycle of that we needed, and use a generator function instead and use yield. And yield would be telling us at this point we would yield this state, and then we've got some space in between that next yield, and we can do some other things, and that means that we can give it successive sets of state. And we would see that normally in our functions where we would have this external state management library, and we'll get some information and we'll return our new state. Instead, we would have our state within our function itself and then yield each new state that we've got. Yeah. Okay, I'll go back to this one here because this one's a bit more important. So you see with most JSX frameworks that you got right now, you will get your children as part of your options, which would be the first argument, that O right there. But we're split it out into a second argument where we can get that information directly and then reference it directly. And in this case, that V node right there is a single instance that we're never going to see. If we passed through that children once, we only will get that update once. And in the case of a function, that kind of makes sense because we've only got one instance of our function. But when we think about a generator function, it kind of splits out a bit more and we've lost something. Because now we've got only one child that we're going to keep over that state. And then the inner state of that is going to be maybe it would get, what's the word? I've forgotten the word. That's okay. So we'll talk about the actual children and how we can get around that in a couple of slides. So we've got here where we've got, if we're talking about that space in between everything, we can go through this example here. And so I don't know if this makes sense. I'm sorry. So we've got this log that we've got, and if we think about it in typically in our normal I don't know how I can explain this, sorry. Okay, so we've got this log here. This log here is our log of everything that's going to happen within our process. And we've got that union happening within this 408 right here. And we've got this component here which is going to yield multiple states. So at one point it's going to log a frog, and then it's going to yield its state, which is a disk. And then it's going to log it's going to go through each one. And we can see here we've got this, it starts at some point, it's got some steps that happen in between, and then between each step it goes on to the next one, and then it finishes. So we can see here it went through 2 steps, it started once and finished once. And then over here, this here went through once, and we can see there's the frog. And then in between each one, we're still getting that log of that. So we see here there's that diamond, and then we've got the yield itself. These yields directly relate to a JSX state that you want to render. So if you're thinking about what's going on and how to relate these two things, you've got some space in between that you can do different steps. So if you think about what you're doing now where you've got a function and you've got multiple changes, you would typically your effects sit right where that diamond is. So between multiple renders, and so you would have an effect first, and then you would have some kind of state change, and that would yield some event that would put out your state. So this is the start where we get very different from what our normal JSX frameworks let you do. So if you think about that whole resolution process within those children, and we can use 408 to consume it, everything within that can be promised to begin with. So right from the start, you can pass a promise directly as a child of your JSX elements. And those will be resolved in the same way as everything else. And because of that, that means that you can use async functions out of the box as well. And so you can define an async function, and that would go resolve just the same way as a promise. So to the reader itself, that there is completely abstract, and we don't see anything about this async function being in there. And to step from there, you go and, because we were using generator functions before, you can also use an async generator function, which means that each iteration you can do, you can return a promise, yield a promise, and that will resolve within that as well. Yeah. So this is where it actually gets very different. So if we talk about what classes are used as right now, typically it's an interface for the JSX renderer itself to give you updates about what some external tool wants you to use as your state. And in our case, what we want to do is we want to define a single instance of our class. So in this, we've got our async iterator still, and we can yield exactly as we were with our generator functions, except for, oh gosh, this one here. Here we go. So we've got our single instance defined here, where we've got node, and we're going to reference it multiple times. But now we've got this reference directly to this, which we can use across our 3 different iterations, which these are 3 separate components that you would kind of think as 3 separate components that were rendered, but they share the same class instance. And given this here, you could use this across your entire stack, where you can have some class right at the top and then have some children class that render it a little bit differently further down below. And yeah, so and with this, because you can use just a normal iterator, we've also got an async version, which does all the exact same thing, except the only difference is that it's async. Yeah. So this is another piece where it's very different from normal JSX renderers, where you would have, if you want to define things where you've got some template that you want to follow, and you want to have some definition where, like for example, a div tag, you might want to call that a box, and then reference that as a box or a view within your component, within your application everywhere. But to the actual reader of this JSX element, you want it to look like a div. So you can kind of swap things out a little bit, and you can build your own set of tokens up. So you see here we've got our different tokens that we create, and then we can create our whole different hierarchy, and we can get our own unique set of output tags that we've got. And this here you would use in a case where you've got some set of generic views or components that you want to set up well beforehand, and you fill out these, and then as a consumer of these JSX elements, we can filter for these here directly, and we can map these to other elements or other components with different state or different transitions that are actually happening within. Yeah. And then we can fill this up even more, where we can have a whole lot of different things. So instead of those boxes, we can have things like, well, these are my actual business objects, where I've gone and defined everything about these business objects, and I can go and read these directly as JSX nodes as well. And this all fills in within that same resolution process of that earlier union, where we can go through and go through each set of transitions that all of these things define. Yeah. So a core thing about this set of software is that it's completely defined as Ecmascript modules. So these are completely just available to use in browsers right now, rather than the common JS, which is a bit harder to use from there. And so there's no roll-up or anything of this whole project. You can use the entire thing as Ecmascript alone. And with that as well, it was also completely built with TypeScript, which means that everything is typed and everything has strong typing around it. And with that, you also have Deno. So along with TypeScript, because it's written in TypeScript, the actual source, it just happens to work on Deno perfectly, and it just works along. So using these 2 scripts here, you would be able to run that in your terminal, and you would get the JSX actually rendering in there. Yeah. So with this whole structure, because it is then TypeScript as well, the actual true types of these JSX elements are created for us, and they're just some byproduct of this whole module. And so you see here a scalar, well that would there be just a single bit of information that we have, and we can see that we defined it as a scalar. It has no children, it has no options, so we can see we've actually got a direct type that it has never going to have, it's never going to have children at all. And this here can be expanded well further, where we can give it full options and whether it's got children down here. So you see this node right here where it's passed a soccer node. The direct type of the children is the type of that soccer node. And we can bring that all the way down here into that for await where we've got that children, and that goes through to that output type there. So this is only ever going to be, from the point of view of TypeScript, this value. And if we can expand this further and further outwards, where we've got more and more structure, and we can create our entire domain of information just within types itself. Yeah. So that's the real key here, is that when you are actually defining your code from the start, it's to be able to use these tokens directly to define your domain of information. So you'd start from the start by defining things like your products, and you'll be able to use, so that same slide earlier, where we've got all of our sets of things. So these would be our things that we put in our application and use them. These can be static bits of information that we can read and use within our JSX directly. Yeah, okay. And then this whole set of software, it doesn't actually define how you do things or how you're meant to do things, because it's defining to just use JavaScript and just use TypeScript out of the box. So rather than saying this is your state management library, it's more saying, hey, go use a class or something, or use something external like, for example, Redux or some other state management tool. And this here is providing the boundary for JSX itself to be able to transform it and use it and consume it in whatever way you might want to use it. And given that, you would also define your own architecture on top of it. So right now, if you were to use other JSX renderers, they give you an architecture that you must follow. And if you don't really follow that, then you're going to get into a bit of a pickle itself. So you would define from the start all your assertions about what your structure is meant to be, and things like that, and really work on it from the other point of view, rather than having to work around your state management library, define what you actually want to do. So when I say architecture, I mean really get a front-end architect and go and design what you want beforehand, rather than just opening your toolbox and going for it. Yeah. Oh, all the examples that I did have on here are on here, online. I don't know why that is. I guess it's my internet. And it was also, everything's available on GitHub, where, as well as all the code that's supporting to be able to do this set of patterns. Okay, I guess I'm getting right to the end. It went a bit faster than I thought, sorry. But key here is that a lot of this work, I've done all of this work to be able to get this JSX framework working, but I've had to do it alone. And that's because we need more people to contribute to open source software. And we're very alone if there's no one reaching out to us and creating issues and feedback and things. But that's really the fuel for open source itself, is you people here, and whether you're actually interested enough to leave a comment or leave some issues. If you find anything, then that's really the thing that we need to know. Yeah. And well, thank you for listening to my talk, which I thought was going to be a bit longer. Yeah. And thanks. Yeah.
Okay, we have time for questions. So who wants to test him on any of this stuff?
Yeah. Ask me anything.
Just pass the microphone.
Hey Fabian, I think that was interesting. How, is any of this in production anywhere, or is it?
Yeah, this slides that you're seeing is made with it. So, for example, each slide has is set as a domain object itself, and all the slides are then, well, they're rendered into the DOM using a DOM node module that framework provides as well.
And I guess the follow-on from that for me is, what's the next steps that you need help with?
Yeah, is for me to go and work on it even more full-time. So in the coming months, I'm going to be working on this to get it, a bit more production ready for everyone, and get that working. So yeah, the next steps is to push forward. Yeah.
Yeah, that was really interesting. Thanks. What kind of use case, what kind of niche would I pick this for over, I don't know, a React or a Preact or something like that? When would I reach for this?
Well, it's where you want to define your own architecture from the start, right? Where you this there is only enabling the JSX component of things, whereas most JSX frameworks you get now are JSX plus. So you get that state management is the core thing that you would get with it. Whereas in this case, I'd say right from the top level of your functions is to define a generator function which is giving each iterative state of your whole application and going through it like that and retaining everything right from the top level. And then, yeah. For example, I've got a website that has 500 DOM nodes that are outputted, and it takes about 100 milliseconds to run with this. But you can just keep on iteratively generating that state over and over again, and you shouldn't be hitting any performance issues whatsoever around that. So you just, right from the top, start again, rethink things.
How does it handle state updates in terms of DOM nodes and stuff? How does it all work?
Work with what, sorry?
Because so if you have some kind of user interactions which are updating the...
Yeah. So for example, these slides here, they're taking events in just for key left and key right. So that's how this one was built. And there's that top level generator. So if you had some generator function, you would have a direct promise, this is my promise for my next click that I've received. Yeah. So and then you use that click that you receive and you go through your normal processes that you normally would do based on around that. So if you wanted to change some state, it could be a let value that's in your scope, and you would be updating it directly. So you don't go define some use callback or something and go through that state. You literally go document.add event listener. Maybe that's actually a very core thing. Is this whole talk. I guess that's why it's hard for me to even talk about it. Is because I'm trying to tell you just to go use JavaScript. That's the key thing I want everyone to go to do. Is just use JavaScript itself. And this here is only the point where we're trying to use JSX itself. So it's the enablement of that only. I think I could also mention one more thing, which is the top level render for this returns a promise. And given that the renderers, the other renders, they actually return nothing because it just creates some asynchronous state that's happening outside of that render loop, and you never actually get to know when that render finishes itself.
Yep. Cool.
Hey, thanks for the talk. I just wanted to know what made you want to start creating this? Did you just wanted to play around with it, or was it
that actually might give you some better details. So I was looking originally for something that can create graphs of, execution graphs is what I was calling it. And that's where I've got a graph of things and a graph of business objects, and I need to do something against that bit of information or graph. And this here is kind of like if you think of a JSX structure as a set of functionless functions, right? They're just things that are they're stateless things that are doing their things within this. But if we blob them all together and say, well, this set of state isn't done until all of the things are done in there, then that's kind of more what we're going for. Cool.
Cool. Oh, yep. just when I was about to call it. We'll make this the last one.
Hi. Could you explain a little bit more about the union function that you had up
Yeah.
there? I
So-
didn't really follow the output that you had on the slide.
Yeah, we can go back to that one. So the union function was something that it actually took me maybe a year and a half to actually produce this one function alone to get this functionality working. And without it, none of this works. So that union function there is the most core. Do you have a specific question about it? Because it might be.
Well, I mean, I'm looking at the output you've got there. Why does the first object not have the other two values?
Yeah, so why does the first one not? Because each one of those horse, bird, and robot, they return a thing called an async iterator. And each one of those async iterators we need to call next on, which returns a promise itself. And by the time we call the next on the horse one, the bird one takes too long to get to. So we already have seen that all the promises are resolved, so we move on to the next one, and that bird gets into the next set of iterations. So it's not that it's lost, it's just that it wasn't quick enough. And so this is the real log that I took right from the output, so I'm not trying to make it easier to understand or anything. Obviously, it's a bit more difficult, but yeah.
I guess is there some simulated time that you've got there?
Yeah, microtasks.
Okay.
That's what's simulating that there. So if I was to, I could optimize this a little bit more and apply my own logic on top of it to make sure that we get all the first sets of horse, bird, and robot. But most of the time, it doesn't really make sense. And you're only seeing this here where we've got horse and then we've got those other ones off because we're doing it all within the same kind of frame. We're not doing anything in between those yields, and we're not doing anything external from it. This is the only code that's running. And so if you run this code multiple times, you'll get that same result multiple times. So it's a deterministic way of doing this union. And in this case, that's what it's figured out the best is. And we could optimize this a bit better. Yep. If you need more clarification, I can take another question on that specific bit though.
I guess the only other question I have is why did you choose to call it union?
Yeah, I don't know. It was called progressive merge first. So I was looking for something to progressively go over each one of these functions, and I wanted to progressively merge them into a single array of each one of its state. And this is the same process that you would this is what happens when you're resolving multiple siblings together and trying to know what they're all up to at once. Yeah. Yeah. Cool.
Cool. Any final questions? Cool. Okay, we're finishing up a little early, so as you file out of here, be careful about making noise in front of track 1 because they'll be finishing up a bit later possibly. Afternoon tea will probably be ready at 3:20, which is about 20 minutes from now, and we will be reconvening at 4 p.m. Please join me once again in thanking Fabian.